Greetings to the CMP 1001 Introduction to Programming with C++ series. In this video, we will continue looking into the variables, as well as look at the basic operators in C++ language. Variables are, as we have mentioned in the previous video, extremely important and key elements to any program. They basically define memory devices or storage places that can be used to keep values in the program. When you declare a variable in C++, you are required to declare two things: the type of the variable, followed by the name of the variable. In this simple example, I'm declaring a variable of type integer, and I'm just giving it the name number. After declaring the variable, I'm just putting down a value of 45 inside that variable. You can imagine it like you have a box, and you are putting this value 45 inside that box. Unless you re-put another thing inside that box, that value will be kept inside safe and sound. Note that it's generally good practice of initializing a variable after declaring a variable. Initializing means just putting down the initial value. So instead of writing down just int number, it would be a much better approach if you just say int number equals 0. Because depending on the compiler that you are using, they may not initialize the variable, which can cause you problems in the longer run. Any variable has three main features: the type, the name, and the value. When you declare a variable, you clearly specify its type, and it cannot be changed throughout the program. The name is also similar. When you declare a variable, you have a very well-defined name, and the name cannot be changed throughout the program. No two variables can have the same name, regardless of their types, in C++. However, there is something called the scope of a variable, and when we mention the scope in the upcoming video lectures, we will mention that in multiple scopes, you can have variables with the same name, which can cause problems, which can cause confusion, but this is something that you are able to do. The third feature, the value, is basically the thing that, the variable stores. And that thing can change over time based on whatever you are doing with the variable, hence the name variable, changeable. In C++, we cannot actually choose whatever name we want for any variable. There are certain rules for variable naming. First and foremost, the variable names must consist of letters and digits. The underscore character and the dollar sign are also acceptable. However, unless you are doing something very special, it is recommended that do not use this underscore and dollar sign. Second, you cannot use any non-English characters, such as Turkish characters, in variable names. Even though you can rewrite your non-English, these Turkish, German words as if they are like English, as if using these English letters, generally as a programming habit, it is common practice to use only English words. Third, the names of the variables must begin with letters. Even though digits are acceptable, they cannot go as the first thing inside the variable name. Again, you can start the variable name with underscore and dollar sign, but again, it is not recommended since generally library routines, library functions often use such names. Fourth, C++ is a case-sensitive language. So if you are writing down int x with lowercase x and int x with an uppercase x, these are actually two different variables. And last, keywords such as int, main, float, return, long are called reserved words, and they cannot be used as variable names. In many IDEs, these keywords, how do you notice them? They just gonna be colored with a different color. For example, C-line just colors them with a dark purple, so that you can easily notice these things. In addition to those rules, there's also a suggestion in variable naming. Although the language doesn't require that variable names are meaningful, it is generally strongly recommended that you use meaningful names. So whatever that variable is used for, that the name of the variable should reflect that use. Alright, let's look at some examples. The first one here starts with digit 8. Therefore, it just becomes an invalid variable name. The second one is all composed of digits. But the problematic thing here is again the same thing. The first character here is a digit. The third one, number plus, starts fine, but then the plus sign at the end just messes things up and it just becomes invalid name because of this plus sign. Fourth example is the same. the backslash and the percent makes it an invalid. The fifth variable name looks like a valid variable name, but if you are careful, notice that there is a blank between the x and the 9. So you cannot put any blanks inside the variable names, therefore this is an invalid variable name. The last one is a reserved word, so that is again an invalid variable name. Some valid variable names can go like this. I'm here using the underscore a lot, although as I mentioned, it is not super recommended to use these kind of variable names. The fifth one, the fdjkfh, that thing, is actually a valid variable name. However, it is generally a very terrible practice to use such a variable name because it just doesn't explain what is this variable used for. Same goes with the last one. The last one is the fixed version. So now between the x and the 9 there are no blanks, there are no spaces. So this is technically a valid variable name. However, again, this is completely meaningless and it is a very terrible variable name choice. These rules also apply to other identifier names, such as the function names and the class names that we will see in the upcoming lectures. In addition to the three features of the variables, you can also put identifiers in front of the variable type when you are declaring a variable. A classical such example is the const identifier. If you put the const identifier in front of a variable while declaring it, it just becomes a constant instead of a variable. So you can only put value to that variable once, and afterwards you are not able to change the value of that variable at all. A classical usage is the mathematical value pi. So here, instead of writing down double pi equals 3.14, I'm just saying const double pi equals 3.14. I'm just reminding any potential programmer that's going to use my program or myself in the upcoming weeks that this is a constant variable, so its value cannot be changed. By convention, only capital letters and underscore character are used while you are naming a constant. Let's look at an example with this constant pi. Write down a program which reads the radius of a circle and then calculates the circumference and area of the circle using the pi constant as shown above. So I declare a double variable for the radius, and then I'm gonna declare several more variables. Circumference, just to keep the circumference value at the end, and similarly the area. As for the pi, I'm just saying const double pi equals 3.14. I'm also initializing it so that there's gonna be no potential problems. I get a value from the user and put it inside the variable radius, and then I calculate the circumference with the classical circumference formulation. 2 times pi times the radius. Similarly, I calculate the area with pi times radius, because this is pi times square of r. Finally, I just write down Alright, let's run this code. Let's look at something simple. So I'm just giving 10 as radius, and the area is 314, and the circumference is 62.8. Alright, so let's assume that after getting the radius as the input, I have a change of heart, and I just want to set the value of pi to simply 3. Here, as you can see, this should work, because this is a regular assignment operator. However, there is an error. What is the error? Cannot assign to variable pi with the const qualified type const double. Since I put the const identifier in front of the variable, now I am unable to change the value of the variable. If I simply delete this thing, as you can see, the code at line 12 completely becomes a valid code. Consequently, as I mentioned, you cannot change the value of a constant variable after you declare a variable as a const. After these discussions regarding variables, their namings and their usages and identifiers, let's now turn our focus into the operators in C++. As you can see in here, there are a variety of operators available for us to be used in C++ language. Some of these operators are more mathematical operators, like the assignment, arithmetic, compound, increment, decrement, and the bitwise operators if you are doing something with the binary. The comparison and the logical operators are more related to comparisons, logical comparisons, like to be used in if clauses, while clauses, do while clauses, and so on and so forth. There are additionally other more sophisticated looking operators also available for us in C++. In this part, we'll be focusing on the four mathematical ones: the assignment, arithmetic, compound, and increment, decrement. When we talk about the if and the while in detail in the upcoming parts, we'll be talking about the comparison and the logical operator, and after a while we'll also look at the bitwise operators in a separate video. Assignment operator is one of the most common operators that you will see in any C++ code. It just simply looks like this: something equals something. So the component of the left hand side of the equal sign is called the left value. The component at the right side is called the right value. The functionality of the assignment operator is calculating the value of what is on the right hand side of the statement and assigning this value to the variable on the left hand side of this statement. So the left hand side of this assignment operator must be a variable, only a single variable. You cannot put anything else to the left hand side. On the other hand, to the right value, you can put a variable, a value, or a combination of them with any operators that you can think of. A simple example is like x equals 5. In this scenario, the right hand side is composed of a single value. He will just gonna take the 5 value and put it inside the variable x. The second one is a little bit more complicated. There are two summation operations and there is a variable in between. So first of all, he will just go to the variable a, and let's say its value is 3. He's gonna take the 3 and put it inside the a. Then he's gonna execute the summation operations from left to the right. So 6 plus 3 will become 9, and then 9 plus 2 will be 11. Then he will be simply putting the 11 value to the variable x. These left hand side left value and right hand side right value things are called value categories in C++. And currently they are called the C++ 98 value categories, like an older version of value category system. Starting with C++ 11, there is a more sophisticated, more complex value category hierarchy, as you can see here. But these things are a little bit more sophisticated for our users for this particular video series, so I will not be going deeper inside these C++ 11 value categories, and for the rest of this video series I will refer to the C++ 98 value categories. For those who are interested in the C++ 11 complex value categories, you can just refer to the cppreference.com. There's a pretty good explanation in that website. We mentioned in the previous part that each variable type also has a size in terms of bits. So we said like the integer could be like 16 bits, 32 bits, even 64 bits depending on the hardware. Whereas the doubles, floats have fixed sizes. Let's assume that we have such two variables, the integer number and the double number. And as a good programming practice, we just initialize both of them with 5 and 7.67. The question is, what happens if I try to put the integer number inside the double number with the assignment operator? And we can also do the reverse. We can put the double number inside the integer. Since the sizes of an integer and a double are not the same, how the C++ compiler will handle these kind of scenarios? The one on the left is called promotion, and the one on the right is called a typecasting. Formally, promotion is like this. When a narrower fundamental type is assigned to a wider one, the value is assigned without losing information. And this is done automatically because, an integer can also always fit to a double because an integer numbers are a subset of the real numbers. So no problem there. So promotion is pretty straightforward and pretty simple in C++. However, the other way around, is handled by typecasting. When a wider type is assigned to a narrower type, then it is typecasted implicitly. The type will be changed. However, it is highly recommended that you should use appropriate casting operator and do what is called an explicit casting. Let's look at the promotion a little bit in more detail. So the valid promotions between fundamental types are given in this table. So as you might imagine, the long double is the biggest available fundamental type, so it cannot be promoted into anything because, well, it is the biggest. Double can be promoted into long double, float can be promoted into long double or double. Long int is pretty big, so it can either be promoted into a long double and double, and it goes on and on like this. The simplest variable, the boolean, the smallest one, can be directly promoted into any type of variable, any type of fundamental variable. Okay, we mentioned in the typecasting that it's a bit more sophisticated than the promotion, and there are two types of typecasting. These are the implicit typecasting, when you simply put a wider value into a narrower one without doing anything, as in our example, saying like integer number equals double number, then C++ automatically casts the wider value into the narrower value by some rule that is defined by that particular compiler, which generally you don't have any control over. So that's why implicit typecasting is considered to be very dangerous. The other way, safer way, is explicit typecasting. Here you just do the same thing. In front of the wider value, you use an explicit typecasting operator and say to the compiler that I want you to turn this value into the smaller value according to the typecasting operators, how they behave. So what are these typecasting operators? For every single variable type, there is a corresponding typecasting operator. It is pretty straightforward, as you can see from these tables. You just write down regular parentheses around the type that you want to be casted into. So if you want a double value to be casted into an int, you just write down within regular parentheses I and t. And then the double value will be turned into an int according to the typecasting operators. So in this particular example, where I'm trying to put 7.67, a double value, inside an integer variable, the casting operator will simply take the part before the decimal point, 7, and then put that part inside the integer number variable. The part after decimal point doesn't fit inside an integer, so he will completely remove that part. He will truncate the 7.67 into 7. So no matter what, after the decimal point, it will become 7, regardless of being 7.00001 or 7.99991. All of such values, all of such real values will be truncated into 7. Let's look at this thing in an actual coding, because promotion and especially the typecasting is a little bit more sophisticated in theoretical knowledge, and it's much better to explain it via an actual code piece. So here he says, write a program that declares one integer and one double variable, initializes them both with a valid input, then copies the integer's value into a double variable, and then puts a real number into the int variable. Alright, so I am gonna declare my integer number, and I'm gonna put 5 here. I will have the double number, and I will have the 7.67. Then I will continue with just writing down these values to the screen, saying that the integer number's value, or maybe just simply integer number equals integer number, and similarly double number equals double number. Okay, then I'm just gonna say double number equals integer number and print this part to the screen. Afterwards, I'm gonna say integer number equals, for example, 5.68, and write it down like this here. So here on line number 16, I'm just doing an implicit typecasting. If I try to do it with an explicit typecasting, I'm just gonna say int, for example, 9.876. Let me run the code. Before just doing anything, as you can see, integer numbers value is 5, double numbers value is 7.67. Here at line number 11, what I'm doing is I'm just putting this 5 inside a double. Integer is a smaller sized thing than a double, therefore this is a promotion. Nothing problematic is happening here. 5 is technically converted into 5.00, but cout just doesn't write down the .00 part, so he just puts out as the output, as you can see, double number equals 5. Here in line 16, I am just actually using an implicit typecasting, and cline is actually showing me that I'm just doing the implicit typecasting. Implicit conversion from double to int, and he's changing value from 5.68 to 5. So he's telling me that although you have written 5.68, what is happening is he just casted this thing into 5 in secret. But the thing is, this is how my compiler, in this case the MinGW, behaves. Normally this is, as I mentioned, a bit of a problematic and a dangerous situation, because it does not, the compiler can choose to implement this thing in a different manner. It could have been something like, if this is if the number's value is between 5 and 5.499999, then just cast it down to 5. But if the value is starting from 5.5 and goes all the way up to 5.999, then just round it up and make it 6. It was also possible. So I don't have any control over that. How do I have control? Then I just have to use the explicit typecasting operator in line 21. Instead of writing it like just a number, I just put the int, the typecasting operator of int, within parentheses, and now, as you can see, cline is not giving me even a warning, because he's now sure that regardless, this is gonna behave according to how the typecasting operator works. And how does it work? He just truncates the part after the decimal point. And as you can see, the integer number's value is just 9. The part after the decimal point is completely removed because, well, it doesn't fit to an integer. So this is basically how your typecasting, implicit and explicit typecasting, works. Okay, after this typecasting operators, now let's look at the arithmetic operators, the more classical operators, the summation, the subtraction, multiplication, division, and the mod operation. These can be applied to all fundamental types, including the bool. There's a little bit of an exception though. The mod operator, as you might be imagining, it's just defined over the integer number sets, so you cannot take the mod of a double with another double value. So the summation, subtraction, and multiplication, as well as the mod operations, are pretty straightforward. But when we look at the division operator, there are actually two variations of this operation. The first one is called integer division. If both operands of the division operation are integer numbers, then it just truncates any fraction part, any part after decimal point. When you try to divide 5 by 3, the result is gonna be 1. But if what you are trying to divide is 5.0 divided by 3.0, then, so it means like if at least one of the operand is a float, double, or long double, then it becomes a real division. So in this scenario, 5.0 divided by 3.0 will become 1.666. So it will also calculate the part after the decimal point. So let's look at this thing with an example. Write a program that reads two numbers as integers, then calculates the division of them via the integer division first, and then the real division. So I will be declaring two numbers. I will be calling them number A and number B, not so surprisingly. Then I want the result to be declared inside a double variable. I'm gonna get the values from the keyboard. Then first things first, I want to conduct a simpler integer division. Let me run this simple looking thing, and I will to show you that the 5 divided by 3 will actually result into 1. So 5 and 3, and my result is 1, because since both of the operands are integer values, the resulting division operation is an integer division. But how am I gonna change it into a real division? I mean, one way that you can think of could be just changing at least one of these variables into a double, but let's try to stick with the scenario where I want these variables to be integers, but I want this calculation, this division, to be conducted as a real division. So the typecasting operator comes to our help in this scenario. If I just put this typecasting operator of double here, let's see what the result will be. So 5, 3 again, and the result is 1.66667. So what is happening here is, as you can see here, before the division operation takes place, I just tell to the compiler that first convert the value of number A, which happens to be 5 in this scenario, into a double value. So the 5 will become 5.0, a double 5. And now he will be trying to divide a double 5, 5.0, by 3, an integer. Both things are not the same type. He will just gonna promote the 3 to 3.0, because in all of the arithmetic operations, the types of the both operands must be the same. If not, the smaller one will become promoted to the bigger one. That is how the arithmetic operators work. So consequently, 5.0 will be divided by 3.0, and then the result will become 1.66667. I can continue by just adding the same thing in front of the number b, and I can also delete this double in front of number a, which will yield the same result, because as the rule says, at least one of them being double is good enough. He doesn't need both of them, or he doesn't need the first one to be a double. One of them to be double is enough. So again, 5, 3, and the result is still the same. Another classical trick that people just do instead of using the typecasting operators is just multiplying this number by 1.0. In this case, again, as I mentioned, let's try to solve this one, the one on the right hand side. 1.0 is a double. Number a's value is an integer. I cannot multiply a double with an integer, that there is no way for that. I have to promote the simpler one, the smaller one. So I will be promoting the 5 into 5.0. So now 1.0 times 5.0, surprise, surprise, 5.0. Now this is a double, and I'm trying to divide that one with an integer, and then, as you know, the same things will be happening. So the result will still be 1.66667. So this is the main division between an integer division and a real division. There are other alternatives that you can try, but all of them will follow the same basic rule. If both of the operands are integers, then the division will become an integer division. If at least one of these operands is either a float or a double or a long double, then the division will become a real division. Now let's look at some double int interactions using various arithmetic operators. So here I would like to declare a couple of variables. Some of them will be integers and some of them will be doubles. I will have the int x, double y, they will constitute the inputs. So I will take one int value and one double value from the keyboard. Then I will have a z, which is gonna be an int, and finally a t, which is gonna be a double. Z's value is gonna be x plus y. Z is an integer, x is an integer, but y is a double. So we'll see how these two things will interact with each other and what's going to be the output. Afterwards, after this operation, I want to write down the values of every possible variables I have in my system so far. Okay, I clearly stated that x's value is this, y's value is that, z's value is that, and t's value is that. Before doing just that, I also want to say t equals also x plus y. This is another interaction. Here x is an integer and y is a double, but this time t, where the result of this x plus y will be stored, is a double. So let's see how these two things will interact with each other and the value of z and t will be. So I'm just going to say, for example, 78, 9.12. So z's value is going to be 87, whereas t is going to be 87.12. Let's look into detail about how these two lines work. So in line 13, I'm just getting x and y. X is an integer and y is a double. So this is a mathematical operation where the operands types are not the same. So in this kind of scenario, C++ just promotes the variable whose type is smaller to the one whose type is bigger. In this scenario, x's value, which is 78, is going to be promoted into a double, 78.0. Then the summation operation will take place. So it becomes 78.0 plus 9.12, which will turn out to be 87.12. However, this is a double value, but z, the left-hand side item of the assignment operator, is an integer. So he cannot put an 87.12 into an integer, so he will just cast it implicitly to an integer, so the z's value will become 87. On line number 14, on the right hand side of the assignment operator, same thing takes place, and the result is going to be 87.12. However, this time it does fit into a double because 87.12 is a double and t is a double, and as a result t's value is, as you can see, 87.12. Let's just now warp the inputs so that we are gonna be giving him an double first and then an integer, and then see how does our program will behave. Normally our program is expecting an integer first and a double second. Here I'm gonna tell him 42.31 and 7.61. Okay, the inputs are not what I have expected. The 42 goes to x, which was most likely what I have expected, but then instead of taking 7.61, he just took 0.31 as the y's value. Here the trick is, since the first thing that I'm reading is to an integer, he just take 42. And the part after the decimal point, this .31, is now taken as an input to y, which becomes 0.31. The second input that I thought, the 7.61, is actually inside the buffer of the stdcin, so it has never been placed in any one of these variables. So the 42.31 becomes actually two inputs because of the mismatch, the type of the input and type of the variables that I put the input into. Now let me try with the mode operator and how do the mode operator work in this kind of scenario. First of all, I immediately notice that none of these lines do work. And when I go here, C lines tells me invalid operands to binary expression. As we mentioned before, the mode operator is only defined over integers. And since y is a double, we just cannot calculate the outcome of this operation. This operation is not defined over double values. What we can technically do is we can just cast the y's value into an integer, and then we can actually have a result. Let's give him some proper input this time, 7 and 2.34. So x is 7, y is 2.34, and z is now actuality. What happens is 7 mod 2, which is 1. Line number 14 is also giving me 1. Because again, 7 mod 2 is 1, he converts that, implicitly converts that into 1.0, but again, because of the code, he just prints out only 1. Lastly, let's check some character-integer interactions and then see how these two different types of variables operate with each other. For this example, I will have one char ch, one int x, and again, consequently, I can say something like int y and double z. I'm first getting the character inside ch. Afterwards, I'm just getting one integer number from the keyboard. Then I'm just doing something similar, y equals ch plus x, and similarly z equals ch plus x. Finally, we are just putting the classical code as such. So ch colon ch, x colon x, y colon y, and z colon z. The program is expecting me to give him one character followed by a number. So let me give him capital A and then 5. So ch equals capital A, x is 5, and y is 70, z is also 70. As we mentioned before in the first part, how does the C++ keeps the characters in its memory? By just referring to their ASCII values. And we know that the ASCII value of capital A is 65. Therefore, in line 13, when he's trying to add up one character with an integer, again, he just checks these two things have different types. Who has the bigger type? The integer is the bigger type. So then he has to promote the character into an integer. And when he's promoting a character into an integer, he just takes the ASCII value of that character and then converts into an integer. So capital A becomes 65. And 65 plus 5, 70. 70 is an integer, and I can safely put it inside an integer, no problem at all. At line number 14, something similar happens on the right hand side, but again, when he's trying to put that 70 inside the double z, he just has to cast it into a double, but then, according to how code works, we only see 70 instead of 70.0. Let us try with a little bit different input. Here I will be giving him 12 as the first input and 3 as the second input. And the result is a little bit different than I might have expected. CH is actually 1 now. He only took the 1 of the 12, and then x become 2 because of the same thing that we have seen in the double integer example, the previous example. So CH is only expecting a single character, so he only took 1 of the 12. Then the 12 is, an input, so it is an integer, and then x becomes 2. The 3 is an unused input in this case. So 1 has an ASCII value of 49 as a character, so 49 plus 2 becomes 51, and both outputs become 51 in this case. Notice that even though I have given him all numbers, how does C++ behaves and how the output becomes 51 is a little bit different than what you might expect. But again, when you are dealing with characters and non-character variables, you always have to consider the ASCII/Unicode values. Another group of operators is the compound operators. This is basically a combined arithmetic and assignment operator and is generally used to shorten the code. So instead of just writing down x equals x plus y, you can say x plus equals y. So he simply combines the assignment and the summation operation on the x equals x plus y, and he just makes it x plus equals y. There are similar compound operators for the multiplication, for subtraction, and for division, as well as the mod operations. And they all work as you might expect. Generally, the compound operators are used to shorten the code, but from a functional point of view, they don't offer you any additional benefits. The last group of mathematical operators is the increment and decrement operators. Again, this is similar to the compound operators. The plus plus and minus minus are the increment and the decrement operators respectively. Plus plus simply adds 1 to the operand, whereas minus minus subtracts 1 from the operand. You simply write n plus plus, which just increases the value of n by 1, or n minus minus, which just decreases the value of n by 1. So I will have n, and as a starting point, let's say the initial value of n is 7. And then I'm gonna say n plus plus and write down the value of n. There's another version of the increment operator, a prefix version of the increment operator. So it goes like plus plus n instead of n plus plus. Let's also try this one out and see on their own how do they work. So after the plus plus operator, the postfix increment operator, n's value becomes 8. And after the prefix operator, plus plus n, n's value becomes 9. So when you use them like this, they are exactly the same. They just increment the value of n by 1. But if we combine them with another value, such as m, then how these things work will change. So let's have another integer variable called m, and I'm just gonna say m equals n plus plus and m equals plus plus n. So I will also update the code so that it also prints out the value of m in addition to the value of n. Here, as you can see, the values of m are quite different. Here the first output shows that m's value becomes 7, whereas n's value becomes 8. The increment operator increased the value of n by 1, so n's value becomes 8. But then you might expect that the m's value should also be 8. However, the postfix increment operator, the n plus plus, just takes the value of n, puts it inside the assignment, so m's value becomes 7. After the assignment, he increases the value of n by 1. Hence, n becomes 8, whereas m stays at 7. However, the prefix version of the increment operator works in the reverse order. So first, he just increments the value of n, then takes the new value of n and puts it inside the m. Therefore, m also becomes 9 in this example. If you look at it in a more formal manner, the postfix increment operator assigns the value of n to m, then increments n's value by 1. The prefix version increments the n's value by 1, then assigns the value of n to m. As you might expect, decrement operators, both the postfix and the prefix versions, work exactly the same as the increment counterparts. Before finishing this part, we can also talk about something called the comment lines. C++ allows us to remark a particular line or multiple lines as comments. These comment lines are going to be completely ignored by the compiler, and they will not be considered as part of the program. Instead, the compiler will just assume that these are some self-notes of the programmer. So it's going to be useful for the programmer, and it has nothing to do with the program. To tell to the compiler that a particular line is a comment line, you have to put 2 slashes at the start of the line. Or alternatively, you can put a slash followed by a star, which means that this is going to be a start of the comment, and then finalize it with star and slash. So any code between these two remarks will be considered as comments. C++ will completely ignore the lines considered as comments, and it's not going to be part of the program. It's not going to be compiled using the C++ compiler. In this video, we have looked at variables in a more formal manner. We talked about variable naming rules as well as some identifiers. Afterwards, we looked at the operators in C++, and in particular the mathematical based operators, the assignment operator, the arithmetic operators, the typecasting operator, the compound operators, and also the increment-decrement operator. In the next video, we will look at the conditional statements, the if clauses in C++. Thank you for listening, and see you in the next video.